What we're going to be looking at here is finding the inverse of a function using function notation. We're also going to be finding out what the domains are both for the original function and its inverse. Lastly, for the inverse, we're going to determine whether or not what we write is a function itself. Remember, every function has an inverse relation, but not every inverse relation is a function on its own. The function we're going to start with is f of x is equal to the positive square root of x minus 3. Before we begin, let's talk about the domain of this. By domain, I mean to ask the question, what values, if substituted for x, will result in a non-real answer? Now, I know that we can take the square root of any number, and if we allow for imaginaries, it'll work. But we want to constrain ourselves just to the real numbers. So are there numbers that would result in a non-real answer? In order to take the square root of x minus 3, we have to set the limit that x minus 3 must result in a value greater than or equal to 0. So that means that x itself must be greater than or equal to 3. As long as that's true, this function will return real values. I can plug numbers in for x and get an output that is a real value. Another way to write this domain is to say that the domain is the set of all x such that x is greater than or equal to 3. And that would be a set notation way of writing it. Now that we have our domain for our original function, let's talk about finding its inverse. Remember, the strategy we learned for inverses is to swap the x and the y. So the first thing I'm going to do is rewrite this by replacing f of x with y, the output value I would get when I graph. So y is equal to the square root of x minus 3. Now, when I proceed to find its inverse, my first step is to swap the x and the y in the equation. I do that because my objective is to solve that ultimately for y. I need to get rid of a radical, so I'm going to square both sides of the equation. So that gives me x squared is equal to y minus 3. Remember, I was accomplished by squaring both sides. Now I'm going to add 3 to both sides of the remaining equation. My result is that x squared plus 3 is going to equal y. Now I can ask myself the question, this inverse, f inverse of x equaling x squared plus 3, is that itself a function? Are there values that if I insert for x, so I put something in, that will result in 2 outputs for y? And from what I can tell, there doesn't seem to be. Every number I would put in here for x will only yield 1 output. If I were to graph this, I know from what I've done in previous classes, this will create a parabola. Parabolas are by nature functions. So that checks out. The last thing I might ask is, let's talk about the domain of this. So the domain for this particular function, again, I ask the question, what values of x are going to break it? What values of x will result in a non-real output? Since I'm taking my number and squaring it, I can square any real number and get a result. My domain in this case is going to be all real numbers. So I make that r with the extra bar. Remember, that stands for all real numbers. Last I'm going to do is here do a short check. Let's come up here and let's actually run a number through this to see if my inverse does what I say it will do. F of x is equal to this. So let's test the point 19. F of 19. So that means f of 19 is equal to the square root of 19 minus 3, which is the square root of 16. And again, remember we said we were going to limit ourselves to the positive. And that gives me a result of 4. So let's go ahead and see what happens when I do the inverse of this. F inverse of 4 is going to be 4 squared plus 3, which is going to be 16 plus 3, which is 19. Remember, with the inverse, what I'm doing is I'm reversing the process. So 19 goes into the original function, 4 comes out. 4 goes into the inverse function, 19 comes back out again. So this function, x squared plus 3, undoes what the function square root of x minus 3 does do.